sure you put my scissors back.
I'll put it back.
Have a good day.
I was up all night setting for a exclusive. And I aced it, but still.
Was it worth it?
I'll say something to me that's funny, man. Yeah. But things like, you gotta like grade yourself, so like, I keep up the divider, and you give a string test, I'll just scratch it like
Oh, so you just skipped Friday?
No, he was there Friday.
No. Oh, skip again.
Oh no, I guess yeah, he was still sick. But he went to school. He's been sick.
Shit, I thought the quiz was
I
there.
mean, he was too sick.
I just called him.
He wouldn't be able to like march, you know?
Yeah.
Really?
My mom would go to the store and skip my first.
Wait, what did have been in? What do you have for dinner?
Yes.
How do we feel about chicken? Get down with chicken.
In front of that.
You've been nasty?
Back.
Yes.
We're gonna have to take this shit dirty. Are we taking mine? I'm part
We're
of
taking
mine.
our car.
Okay.
I'm not gonna lie. I'm leaving for one of those actually.
Oh shit, I knew it was tomorrow.
No. I got a bunch of shit.
Are you gonna drive to?
Actually, Logan, he knew we should go because
So we'll go for a computer. Probably park at RVs and then
here.
Sonic did.
Sonic, they will tell you.
Where were you?
I learned that lesson in
Yeah.
block.
I like to hear that.
Arby's
This will be all sweet, but you go to.
Free chicken biscuits.
I remember that.
Guess who forgot that page notes?
Bro.
Chicken biscuits.
That's why, yeah. Before school.
I would have done them in advisory book.
But you skipped it.
Yeah, to do other things,
That's fine.
such as go possible.
Oh,
And
that's
think
fine.
about what I'm really mad about when I say that.
I get it now. I didn't get it when I glanced at your professor for what?
You
For what?
Have you done?
Those are better than writing the YSS.
We thought about a moment.
No.
What was number 38?
Or not like a moment, like something. Like tell us what your
This
hobby.
year's.
Demonstrates your character.
I'd be surprised if you didn't try.
I think I did.
I'm like for scholarships right now.
Yeah, probably.
Good morning, guys. Assignment 38 is what I'm looking for here to start class. And to be honest, I don't remember from last week. I have to look. I don't remember how many people turned this in already. Just email it to me. Take pictures and email it to me tonight. Okay, yeah, it looks like most of you turned it in last time, which is why there's not many this time. Okay, so we need to kind of summarize what we have been doing and take a quiz on that stuff so we can move on. Now, again, I have given you this warning a couple times, but this stuff from section, not so much 10.1, but especially 10.2, 10.3, 10.4, and 10.5. So that would be geometric, nth term test, integral test, and P-series test, and the harmonic series. Those are the things that we are going to keep using all the way through Unit 10. So not only do you obviously want to know those pretty well for your quiz on Wednesday, but being very comfortable with those will dictate a lot of how difficult you think the rest of Unit 10 is. So make sure you put in a good effort there. So I don't really have anything new to say about those. I just need to make sure that you're aware of what you're on the hook for. Give you a couple practice opportunities. So I have 5 questions from each one of these sections like we've been doing. So just a small sample to hopefully help identify some skills or formulas or techniques that you need to take a second or third look at. But one thing that I did, and I don't know, if you dislike this, I guess you can do this in a different order. But I did not print these off in the order that we did them. So obviously we did 10.1 before we did 10.2, etc. I put these in the order of what I thought was easiest to hardest. So again, if you really don't like that, you can skim through. 10.1's on the back. 10.4 is right before it, whatever. So if you want to work them in the order we did them, feel free to move around the pages and do it that way. But my thought was, if I put them in order of difficulty for most students, Then the 5 questions on geometric on the first page should go pretty quick. The 5 questions on P-series behind that should go pretty quick. The nth term test might be a tiny bit slower. The integral test is probably the most tedious one, so it's the next to last. And then the only reason I'm saying 10.1 is the hardest at the end just because it's a little bit different. The other ones, you don't really have to know a ton to be able to do those, but I don't know. But that's just kind of my thought process there. So again, feel free to work that what is appropriate to you. I was able to work through most of this last period, and there's a few that say use a calculator, but otherwise please don't be using a calculator. The answers are on the bottom of each page, so make sure you're checking as you go along. And so, best case scenario, you do these 25 questions, have no issues, ready to go. Maybe look it over for a minute or two before the quiz on Wednesday. And then, you know, anything short of that, at least it tells you where you need to study. Okay, is there any questions about our quiz on Wednesday that I can answer, or any questions about what I need from you in this practice room? Okay, so again, everyone has, you know, different opinions on what they think is more difficult or less difficult. But I think the first couple pages of this you should go very quickly through, maybe slow down a little bit. Integral test, you're definitely going to have to slow down some because you're going to have to integrate a couple times. And then in 10.1, they might be asking for something that you don't remember what it is. If it asks for S3, if you don't know what S3 is, you might have to look that up or ask about it. So in that sense, I guess it's a little harder to know what to do sometimes. Okay, and that's it for today. So go ahead and get on that in case you have a lot of questions you want to ask for help on. And of course, I will check in occasionally to see what I can help with. Is everybody still doing okay?
I have almost. I had a bunch of messy.
That's why it gave me the impression of like, it's just when I'm sad, I shake, and then I just like shake extra, so I'm like sitting there on my countertop, and I'm like, no, it's not something about that. Yeah, I'm good.
I'm gonna lock in now because
Alan.
I'm gonna lock in because one of them the drink on me because she always said lock in. Now that let's go.
Simon, Derek, Hayden, Alan. Okay, I did not check in with you guys before lunch to see if you had found something I could help with, so now would be a great time. Again, I realize you're probably not 100% finished with all of this, but is there, yeah, what you got?
Can you do number 4 on the front page?
Number 4 on the front page.
Like 10 points ago.
Yep. All right. Can you, I can't get it to be white very quickly. Can you see that red? Or you want me to try something? Okay. Okay, so one of the things I'm actually going to share with you, Derek, I'm glad you finally came to class, but you need to sit down. One thing I'm going to share with you once I think you guys are finishing up is I purposely marked down all of the places where I had made a mistake when I did this earlier today and finished it up, and there was 3 places I made some careless mistakes. This question number 4 on the front page was one of them. So it's not that I made a mistake other than how I typed it in the calculator. So when it says f of 2.4, that's their way of telling you x is 2.4. So the first term, if I plug in 1 for n and 2.4 n for x, the first term would be cosine squared of 1.2. You okay with that? Okay. And then R, so if you want to write out the first few terms to see that, you can, but since all of that is an exponent over n, R is going to be the exact same thing. You're plugging in 2.4 in for x. And so the thing you're multiplying by is cosine squared of 1.2. Still okay with that? Okay. Now, where I had an issue was I didn't type it in the calculator correctly, because these are both kind of weird. So we just need to, well, the formula I'm trying to use is a1 over 1 minus r. So I did a fraction and cosine 1.2. Now here's where I think the calculator struggles, or maybe it's my understanding here, but if I square this way, I think your calculator thinks you want to square the 1.2 and then take the cosine, but what you really mean is cosine of 1.2 times cosine of 1.2. So you should be able to put that in parentheses and square it, or I don't know, I thought it was just as easy to multiply it by itself because that's squared. Okay, and then the denominator is 1 minus r, which was cosine of 1.2 squared. So again, I just did cosine of 1.2 times cosine of 1.2 because that's the same as cosine of 1.2 squared. Again, you should be able to do parentheses and square it, but if you don't do the parentheses just perfectly, then you end up with issues. Also, if your calculator was in degree mode, you would have issues because you're doing a trig function. So that's how I got the 0.151. Okay, is that enough? Anybody else going to ask about this one? Mark, did you see an ID at your desk when you came in? I didn't. I don't think you did. Sorry. Derek, did you have a question? Number 5 on 10.1. So you are almost finished. Or did you skip around? I said, are you skipping around, or this your last question? Can you see this okay, or do you want me to try to get the background white? Okay. Okay, so the very last question on 10.1, again, I know a lot of you are not there. You do not have to jump ahead, but if you decide you need help with it later, you'll have to watch the class recording. So honestly, when I look at this, again, this is where things start to get harder because you've got lots of tests. They didn't tell you which test to try. It's not obvious what type of series this is. I don't know where to begin. So I literally, in my head, I just have to start going through each thing we've tried. This is not geometric, unfortunately. I could try the int term test for divergence, but the limit of all of that would go to 0, so that would be inconclusive. I could do the integral test if it's always positive, which this is always positive. Continuous, which this is, and decreasing, I don't know if it's decreasing, so I don't even know. The only way I would know if it's decreasing is if I make myself write out the first few terms. So I'm not sure if I could even do the integral test. It's definitely not a p-series test. It's definitely not the harmonic series. So sometimes the only thing I can do to kind of get my feet under me to try to figure out what's going on with this is make yourself write out the first few terms. If you plug in 1, you're going to get 1 over 1 minus 1 over 3. So you get 2/3. The partial sum of 1 is 2/3. Okay, plus, so this stuff comes from n equals 1. plus, let me see what happens at n equals 2, n equals 3, and then a lot of times if you see those first few terms, you can understand what's going on. So if I plug in a 2, I get 1 over 4 minus 1, or a third, minus 1 over 2 times 2 plus 1, which would be a fifth. When I plug in n equals 3, I get a fifth, minus a seventh. Are you starting to pick up on the pattern there? So this actually has a name to it, and this is not a name that you have to know, but this is a common type of series. And when it's this type of series, this is the only realistic way to do it. Make yourself write out the first few terms. This is called a telescoping series. And then what do you think all of that would add up to? If I just keep doing this forever, what's it going to add up to? Good. How did you know that? Doesn't have a what?
Negative version.
Right, so notice you've got a 1 minus a third plus a third, minus a fifth plus a fifth. If you keep going, it would be minus a seventh plus a seventh. That's what a telescopic series is. We've got this first term that never cancels out, but then this term gets canceled out by this term gets canceled out by this term would get canceled out by this. So the rest just end up getting canceled out as you keep going, and so you're only left with that first number. So all of that equals up to exactly 1, and therefore it converges to 1. So I still think that's a good strategy anytime you get stuck on these questions. Make yourself write out the first few terms, and sometimes when you see the first few terms, it gives you a little bit of insight or some hints about what you might need to do. Okay, is that good enough there? I assume that's good enough for everybody else too, if you were that far. Okay, what else have you found?
Did you do 3 on 10.5?
Are you okay with this color, or do you want me to switch it to white?
This is fine.
Okay. Again, I don't mind switching it to white. It's just going to take me a couple minutes to remember how to do it. You said number 3?
Mm-hmm.
Okay, so we have an infinite series starting at 1, plugging it into 3 over 4 plus 1. And then they do some work. They do some of the work for us, and they tell us the partial sum has a formula of 1/4 minus 1 over 4 to the n plus 1. So again, this is mostly just kind of understanding what this is supposed to represent. If you want to know what the first 10 terms add up to, you want S sub 10. So you would plug in 10 for n, and whatever that amounts to is what the first 10 terms add up to. That way you don't have to find the first 10 terms and add them together. It gives you a nice little formula. Now sometimes you have to find that, which is one thing you had to do in question 2, and probably the part I think is the hardest from 10.1, just because it's
I
not...
don't think I'm on that question.
Huh?
10.5. Wait.
You said 10.1.
I said 10.5.
It's okay. Number 3.
Mm-hmm. Yes, please.
Okay, I'm almost entirely sure I know what your problem's going to be here. Okay, so a sub n plus 1 divided by a sub n equals a fifth. And it seems like the sum of all of this would be 50. Therefore, we should be able to figure out what is the first term. So they're making us try this in a different way. They're not giving us the sequence where we can just plug 1 in and get the answer and be done. So here's the part that I think, let me make up a sequence, and then I think it's going to help you understand what this is saying. Is this the right question?
No. They're on 10.2, 10.5, the harmonic.
You know you can stop me right away. You don't have to.
I'm trying to figure out if I'm going crazy or if you're doing the wrong question.
It's Okay. 10.5,
Yes, that one.
number 3.
Yes, thank you.
Okay, when will this and this converge? This is better. Okay, so it's really just like 2 for 1. What type of series is this over here?
Series.
Okay, and a p-series converges if p, well, not necessarily this p, but if the exponent on n is what?
Greater than 1.
Okay, so subtract 5 from both sides. This is the right question, right?
Yes.
Subtract 5 from both sides, divide both sides by a -1. Did you switch the inequality sign?
Yes.
Okay. So for the p series to converge, p has to be less than 4. What kind of series was the first one?
Geometric.
It is geometric. Again, so basically as n gets bigger, you keep multiplying by 3 over p, 3 over p, 3 over p. If you don't see that, make yourself write out the first couple terms, and it's a lot easier to see. 3 over p is what's getting multiplied each time. And of course, then when you look back at this, n is what's changing, so as n gets bigger, you're multiplying more 3 over p's. Okay, so 3 over p, if this is a geometric and I want it to converge, this is my r, and to converge in a geometric, the absolute value of r has to be bigger than 1 or less than 1?
Less than.
Okay. So I want this to be less than 1. So 3p, or I'm sorry, 3 needs to be less than p. So for this one to be true, p's got to be bigger than 3. For this one, p's got to be less than 4. And if you're trying to figure out the values that make both of these converge, p has to be less than 4 but bigger than 3, if you want to write it as a single statement. Okay, let me see if I can figure out how to switch this real quick, and then I'll take some more questions. I really hate this color scheme, so. That was not too bad. Okay, somebody, I saw a few other hands a minute ago. Simon?
10.4, number 2.
10.4, number 2. Actually, what I'll do is I will go ahead and start recording some of these questions. I don't know how many more you guys have. But that way, if you're not this far, there'll at least be a quick video for you to see. Let me see if I already have this one. And on the class website, I do have several videos of some of these questions, but I think I have the wrong page numbers since I didn't print these in order that we did them. So I do have this one though. Okay, so number 2 says, confirm that the integral test can be applied to the series 3/2 plus 3/5 plus 3/10 plus ... Okay, so what, well, it says confirm that the integral test can be applied. So what's one thing that has to be true to use the integral test? Okay, decreasing. Now, it's a trade-off. They didn't give us the sequence formula a sub n, but they did give us the first few terms. So this is a little bit easier to see. 3/2 to 3/5 to 3/10. This is certainly decreasing. What's another requirement to use the integral test? One more time. Okay. They have to always be positive, or at least positive over the long run. Positive, positive, positive. There's no reason to think that's going to change. And then the last one is it needs to be continuous. So doesn't look like there's ever any division by 0. So this is the confirming that you can use the integral test. That's the first part of the question. Then use the integral test to determine whether this converges or diverges. Okay, so the integral test is where we're going to take the infinite series and we are going to rewrite it as an integral from this to this. And since one of those is infinity, I'm going to change it to b and say the limit is it goes to infinity. But what to integrate, you have to come up with the sequence that matches this. So this is when n equals 1, this is when n equals 2, this is when n equals 3. You have to come up with the formula for a sub n that matches this. So what could we do to make that happen? Okay, so the numerator is definitely saying 3, so that's okay. And then you said n squared plus 1. Now, I will admit, when I did this one earlier, I tried something like 2n plus 1, but then I tried it for n equals 1, 2, and 3, and I saw it didn't work. So I had to figure out something else to do. So you were right. When n is 1, you get 3/2. When n is 2, you get 3/5. When n is 3, you get 3/10. If it works for all the terms they gave you, then that should be fine. Now, I told you guys a few minutes ago I was going to share with you the mistakes that I made. This 3 is just a number, so I actually pulled it out front to worry about later, and then I forgot about it at the end. So I got the correct answer at the end, but I did not get the correct answer at the end because it was 3 times too small. I had lost track of this 3. So even though I had it for several steps, I just didn't use it at the very end. Okay, so I pulled the 3 out, so that leaves behind this. Now, this is one of the less common, and this might be why you're asking, if I had to guess. Do you know the antiderivative of 1 over something squared plus 1? I heard an inverse. Inverse tangent. Remember, the inverse functions, inverse tangent and inverse sine, are the only 2 you need to be able to recognize. Okay, so that would be from 1 to b, 3 times the limit as b goes to infinity. So 3 times the limit as b goes to infinity of inverse tangent of b minus inverse tangent of 1. So 3 times, okay, so inverse tangent is asking you what angle has that tangent ratio. So where is tangent 1 on the unit circle? Pi over what? 4. Pi over 4. because tangent is sine divided by cosine, so you're figuring out when sine and cosine are the same. Sine and cosine are both square root of 2 over 2 at pi over 4. This one's a lot harder. Inverse tangent of infinity means what angle does it approach, because it's a limit. What angle would you approach so that inverse tangent, or so that tangent has a value that's approaching infinity? And really, the only good way I know to tell you that is if you know what the graph looks like. So in pre-calculus, we graph the trig functions, and then right here, as this goes to infinity, again, think of tangent as sine divided by cosine. The reason it's going to infinity at this angle is because at this angle has sine is getting as big as possible. You think about the unit circle, sine's almost 1, that's as big as it gets, and cosine's getting to be as small as possible. The smaller you make your denominator, the bigger your fraction gets. So where on the unit circle is sine almost 1 and cosine almost 0? This angle is pi over 2.
Just as inverse tangent should be cosine on the numerator. Sine.
You're thinking reciprocal. Reciprocal is when you flip a fraction. Inverse is when you swap the inputs. So all of that to figure out that that's pi over 2. So I had pi over 4 and then spent 10 minutes trying to figure out why my answer was not correct. And it's because I forgot about this 3. 3 pi over 4. So that's not an easy explanation, especially if you don't remember what the tangent graph looks like. But okay, and I guess I'll just go ahead and share. I had one other thing. Yes. Oh, you're done? Okay. So I told you on the front page, number 4, I didn't type it in the calculator correctly. I just told you on this next to last page, I lost my 3 when I got to my answer. And on 10.3, the first question, I did one of the limits incorrectly. One of the limits was 0, and I said it was a half. I did not look very carefully at the denominator. So. Okay, if you guys have more, please keep them coming. That answered everyone's questions so far? Okay. Then please tell me as you guys get stuck. So we can fill in as many gaps as we can before time's up. fixed the class website where it's a little easier to find the videos, since it was labeled as page 1, page 2, page 3, but the pages weren't the same this year. So if you refresh the class website, it'll be a little more intuitive if you need to use those. And this review today, you're more than welcome to turn it in if you finish early enough, but you do not have to turn it in until Wednesday.
Why did I get a late grade for the integral for Divergence test?
I don't know. Do you have it? Oh, I remember you. Well, it's in your folder up there. I remember now. You didn't do the notes. The proof part was important, and you just said under and over estimates.
Oh, right.
You needed to do that. You can still finish it and get half your points back, but it's important that you know that one. What was the hardest part for you?
I think it was one of the calculator questions.
Just type it in incorrectly?
Yeah. Oh, 10.1, number 1. It was actually pretty simple, but I,
10.1 number 1?
Yeah.
It's fine.
yeah, it was easy, but I just typed it in wrong. Like,
Oh, okay. I thought maybe you didn't remember what it was.
Well, that was the problem. I was, like, I understood what to do, but I misremembered it. Like, so I was just like, forgot, I kept forgetting to add 1. I was just doing how much you added rather than like.
Oh, I gotcha. Okay, that's the easy fix.
And I was just like, oh.
I tried to do it. I didn't realize it said calculators. I was like starting to get some crazy fractions.
5 fourths plus 1 ninth.
Well, I did that one, and then it was like 200 and something, 100 and something. So now I had to go again, and I started looking for a way out. Guys, we've got about 6 minutes, so finish up a question or two if they're short and find a stopping place. Please make sure you write yourself a reminder about our quiz on Wednesday, and please do your best to study as much as you can. I promise it will pay off after this quiz. We're going to be using this stuff directly, so. Did y'all have a long weekend or something? Y'all are extra quiet today.
I had all weekend. I had to wake up I had to be here at 7:30 and then play the violin for like 6 hours on Saturday.
Is that even possible?
No, I'm kind of over exaggerating, but we had a lot of rehearsal and then we had a performance.
Okay. Where'd you go camping?
He won't fix it.
The Buffalo. Who? Hans
ill.
You gotta move out. She's not good. You didn't even know what to do. I know, so.
Well, y'all have a reason to be tired then, I guess. I said y'all have a reason to be tired. Did you ever do 0 hour? Or was that before you?
I think they got rid of that sophomore year, my sophomore year. I did it every week to do it.
The class before first period. We used to offer 0 hours, so 0 hours started at 7:15. Just like,
It was like for athletes.
I think the last year we offered it was when y'all were in 8th grade, I guess. I don't know. Some athletes had to do it so they could do practice in the afternoon, and then anybody who wanted to do it could do it. But the tardy bell was 7:15, so.
No, I moved here sophomore year, so I didn't want it.
My brothers used to.
I only asked because you said 7:30, and I was thinking it's like almost a 0 hour schedule. I taught 0 hour for years, and I loved it. That meant school was over at 2:35. So like I actually had an afternoon.
That's what I don't like about it.
Yeah,
Yeah,
for real.
because when I get home, it's like 4:40 usually. So.
I stay back for like 7, so I get home and just sometimes.
You probably leave school and like just get food, right? You guys do that till like 5. I did that. I remember last year for my trial. Went 8 hours in a row until like 8 p.m. We did have meetings from 4 to 8 every Tuesday and Thursday at the school. And so I literally said no like
It was so funny when I
It was fun. I mean, there's a reason they almost every time I hear one, I'm so upset.
That's a big.
Yeah. But I mean, so what happened was we ended up getting to read.
I didn't get to read that.
No, it was our coach from Montreal. No, they for science school they only go till 5. But we ended up being like the first two finalists in 8 years. So it really helped.
I know, I'm thinking as me as a teacher, I could not do that and then show up and teach.
It wasn't a teacher. It was one of our friends.
He's so much. So he does it Oh yeah.
You like cake?
Nobody likes cake.
Are you serious?
Cake is a lie.
I like cake sometimes.
I like red velvet.
You were talking just last night. You were like, I want to bake a cake every single day.
Do you like pie?
Of course, who doesn't like cake?
I mean like,
One of my classes asked if I liked Mario the other day. And then they asked, a different class asked if I liked music. It's like, oh, there's-
okay, we asked if you liked music.
That was y'all? Okay,
Yes.
well, yeah, I've been making fun of y'all for that.
Do you like pie or cake? I feel like you're a pie person.
Ew, pie is gross.
Pie is so good.
Cake is probably better, but I'd probably eat pie more often because I don't feel like it's as bad for you. Even though it's probably just as bad for you.
Yeah.
Probably. My mom makes homemade crust for pie, so and she likes to make it.
That's dangerous, though.
Oh, it's dangerous.
Yeah, because you want to eat it all the time.
She makes like.
Have a good day. I mean, that's fine when you're young. When you
She just we have to move to one by the other. She just loves it.
Friday, there was a handout, yes. P series some harmonic series. Which, good news is it's one of the easier things, so I don't think you'll struggle very much. So here's this. And then we also, this will be on the class recording where you can talk about something. But now that you've seen some of the major tests, this is just a way to like summarize. If it's this, when does it converge, when does it begin, that kind of stuff. So that's the two things.
she